In the labyrinthine corridors of power, where secrets dwell and the future is forged in hidden labs, the CIA's engagement with advanced technologies like AI and DNA manipulation emerges as a tale not just of scientific ambition, but of profound ethical quandaries. This essay delves into the unsettling arena where espionage meets cutting-edge science, exploring a world where human genetics can be engineered with the precision of a computer algorithm. What happens when the guardians of national security possess the tools to rewrite the code of life itself? As we embark on this exploration, we must ask, how does the intersection of AI and genetic engineering redefine what it means to be human? And more importantly, who gets to decide? The Central Intelligence Agency, born in the shadows of post-World War II turmoil, has always been more than just an intelligence-gathering entity. From its inception, it has shown a deep interest in the frontiers of science, from mind control experiments to the latest in technological espionage. The discovery of DNA's double helix in 1953 paralleled the CIA's growing capabilities, suggesting a possible alignment of goals that extended into biological realms. Parallel to these covert operations, the scientific community celebrated genetic milestones, unaware of how their discoveries could be twisted into tools of power. Thus began a saga of dual pursuits, scientific enlightenment shadowed by darker, secretive agendas aimed at harnessing biology itself. As the 21st century dawned, two revolutionary fields began to intertwine: artificial intelligence and genetic engineering. The stakes were high, the potential boundless. The CIA, known for its relentless pursuit of technological supremacy, could not ignore the strategic advantages these new tools offered. The agency's interest likely extended into projects involving the manipulation of genetic structures using AI, aiming to create assets with enhanced capabilities, or to engineer solutions to complex biological puzzles. The merging of AI with genetic manipulation opened a Pandora's box of possibilities, ranging from curing hereditary diseases to potentially creating optimized humans. This convergence promised to redefine the very essence of life and existence, placing the CIA at a controversial crossroads of ethical and existential dimensions. The ethical implications of AI-driven DNA manipulation are profound and disturbing. The ability to alter human genetics using algorithms designed by intelligence agencies thrusts us into uncharted moral territories. Who decides which traits are desirable? What are the consequences of eradicating perceived flaws or enhancing certain qualities? These questions highlight the potential for unprecedented levels of manipulation and control over individuals and populations. The necessity for stringent ethical guidelines and robust oversight cannot be overstated. Without these, the line between national security and the violation of individual rights becomes perilously thin. The potential misuse of these technologies under the guise of security could lead to scenarios where genetic discrimination and biological surveillance become normalized. Artificial intelligence transforms genetic research by accelerating data analysis and interpretation, allowing for more precise manipulations and predictions. Reports and rumors suggest that the CIA has employed AI to sift through genetic data, seeking patterns and anomalies that could be key to breakthroughs in genetic engineering. Projects may range from modifying physical endurance to altering susceptibility to certain environmental factors. The integration of AI in these processes not only speeds up research but also introduces a level of detachment and potential dehumanization in handling genetic data. This raises significant concerns about the reduction of human traits to mere data points in an algorithm, potentially overseen by an agency with intelligence, not health, as its primary mandate. Allegations and whistleblower testimonies have occasionally surfaced, hinting at covert programs where AI and genetics converge. Imagine a scenario where specific genetic markers linked to aggressive behavior are identified and manipulated to create more compliant or more resilient operatives. While these remain speculative, the technical feasibility of such operations is within reach, making them a point of concern. Documents leaked in past decades, although not directly confirming such cases, provide enough groundwork to suspect that experimental applications involving genetic data are not entirely the realm of fiction. These case studies, whether hypothetical or based on partial evidence, serve as crucial insights into the potential scope and direction of classified research. As whispers of the CIA's ventures into AI-driven genetic manipulation reach global ears, international reactions range from cautious concern to outright alarm. Countries around the world, recognizing the potential military and strategic implications, have begun to reassess their own genetic research policies. The international community faces a double-edged sword: engage in similar research to not lag behind strategically or advocate for a global treaty on the ethical use of genetic technologies. The adequacy of international law in this new frontier is severely tested. Current frameworks are ill-equipped to handle the nuances of genetic data privacy and the potential weaponization of genetic research, sparking a dire need for a comprehensive international regulatory approach. Peering into the future, the integration of AI and genetic manipulation by agencies like the CIA paints a complex picture of potential outcomes. One scenario envisions a world where genetic enhancements and modifications are normalized, leading to significant shifts in societal structures, possibly even creating a genetic divide between the enhanced and the natural. Long-term societal impacts could include changes in human evolution, where natural selection is overridden by artificial selection guided by algorithmic decisions. Such a future challenges the very essence of natural human development, potentially leading to a homogenized population where diversity is undervalued. Experts from various disciplines voice concerns over the CIA's secretive merge of AI and genetics.
Geneticists warn of unforeseen consequences in tampering with human DNA at scale.
And, ethicists argue against the moral implications of such power.
AI specialists raise alarms about the uncontrolled learning capabilities of AI systems, which, if not properly guided, could lead to unintended results in genetic manipulation.
It's crucial to understand these expert opinions highlight the precarious balance between technological advancement and ethical responsibility.
Absolutely. Urging a cautious approach to exploring and potentially implementing these powerful technologies is essential.
The media plays a pivotal role in shaping public perception of AI and genetic manipulation. Sensational reporting can lead to misinformation, which in turn affects public opinion and policy. It's crucial for media outlets to provide balanced, well-researched information to help the public understand the true implications of these technologies. How the media discusses and disseminates information on such a controversial topic can influence the development of regulatory measures and public acceptance or rejection of genetic technologies. The current legal frameworks governing genetic manipulation and artificial intelligence are fragmented and inadequate to address the rapidly evolving technologies. Proposals for new regulations or amendments are often mired in ethical and bureaucratic debates. Establishing clear, enforceable laws that govern the use and limits of AI and genetics is crucial to prevent misuse and protect individual rights. These frameworks must not only cover ethical boundaries but also address issues of consent, privacy, and the potential for genetic discrimination, ensuring that genetic manipulation does not become a tool for inequality. The economic implications of AI-driven genetic technologies are vast and varied. On one hand, these technologies promise to revolutionize industries such as healthcare, agriculture, and biotechnology, potentially curing diseases and increasing food production. On the other hand, they pose significant risks of economic disruption, as traditional jobs are transformed or rendered obsolete by new capabilities. The potential emergence of new industries, centered around genetic modification and AI, also raises questions about economic accessibility, and the divide between those who can afford genetic enhancements and those who cannot. The knowledge that one's genetic traits can be artificially manipulated brings profound psychological impacts. Individuals might experience anxiety over the authenticity of their abilities and traits, leading to identity crises and social dilemmas. Societally, the normalization of genetic manipulation could shift cultural norms and values, potentially valuing certain genetic traits over others, and impacting social dynamics and self-worth perceptions. These adjustments require careful consideration and guidance to ensure that society can integrate these technologies without diminishing individual self-esteem or societal cohesion. To navigate the ethical minefield of AI and genetic manipulation, stringent guidelines and robust safeguards are essential. These should encompass not only the scientific and technological aspects, but also consider the social, ethical, and psychological impacts. Mechanisms for enforcing these guidelines must be transparent and involve public participation to ensure they align with societal values and expectations. The development of international ethical standards, possibly under the auspices of global organizations like the UN, could provide a framework for uniformity in practices and prevent ethical lapses in research and application. The handling of genetic information raises significant confidentiality and privacy concerns. The potential for hacking and data breaches could expose sensitive genetic information, leading to privacy violations and potential misuse. The implications of having one's genetic data compromised are far-reaching, affecting not only individual privacy, but also potentially impacting insurability, employability, and personal security. Strong data protection laws specifically tailored to genetic information are necessary to safeguard individual privacy and prevent unauthorized use of genetic data. The military applications of AI-driven genetic manipulation are both intriguing and horrifying. The potential for creating super soldiers or genetically tailored agents brings ethical dilemmas into the realm of international security. Such developments could trigger a new type of arms race, not with traditional weapons, but with biological enhancements. The implications for international peace are significant, as nations may feel compelled to engage in similar research to maintain a strategic balance. This necessitates a global dialogue on the militarization of genetic and AI technologies to prevent escalation and ensure collective security. As AI and genetics merge, intellectual property issues become complex. Who owns the rights to a genetic modification? How are these rights enforced across borders? These questions are crucial in a landscape where genetic technologies can lead to significant profits and competitive advantages. Addressing these issues requires international cooperation to establish clear guidelines on intellectual property rights in the context of genetic modifications, ensuring fair access to technologies and preventing monopolies that could hinder innovation and accessibility. The environmental impact of genetically modified organisms, or GMOs, created through AI technologies extends beyond traditional bioethical concerns. The introduction of genetically altered species into the ecosystem could have unpredictable effects on biodiversity and ecological balance. Environmental impact assessments must be integrated into the research and deployment of genetically modified organisms, ensuring that environmental considerations are prioritized alongside scientific advancements. The implications for public health are profound, with AI-driven genetic technologies offering both unprecedented medical opportunities and significant risks. On one hand, the potential to eradicate genetic diseases and enhance human health is tantalizing. On the other, the risks of unintended consequences and the spread of genetically modified traits through the population raise serious safety concerns. Robust safety protocols and emergency measures must be established to manage and mitigate these risks, ensuring that the pursuit of medical advancements does not compromise public health. In the public arena, the line between science fiction and reality often blurs, especially in discussions about AI and genetics. It's vital to distinguish between what is currently possible and the speculative scenarios often portrayed in media and literature. This distinction is crucial for setting realistic expectations and forming grounded policies. Educational initiatives and public outreach can help clarify these distinctions, fostering a more informed and rational public discourse on the capabilities and limitations of AI-driven genetic manipulation. Advocacy groups and activists play critical roles in shaping the development and regulation of genetic technologies. By raising awareness, challenging unethical practices, and lobbying for protective legislation, these entities help ensure that technological advancements do not override ethical considerations. Case studies of successful advocacy efforts provide valuable lessons on how public pressure can lead to significant policy changes, emphasizing the power of informed and engaged citizenship in steering technological development in ethical directions. Transparency in governmental and corporate activities involving genetic and AI technologies is crucial for maintaining public trust and ensuring ethical practices. Without transparency, the potential for abuse and corruption increases, undermining the benefits these technologies may offer. Mechanisms for accountability, such as oversight committees and ethical review boards, are essential to enforce transparency and ensure that activities are conducted in an ethical and legally compliant manner. The concept of technological sovereignty becomes increasingly relevant as nations seek to control their technological destinies in the realm of genetics and AI. Ensuring that countries have the knowledge, capabilities, and regulatory frameworks to manage these technologies responsibly is crucial for maintaining sovereignty and preventing dependence on foreign technology. This involves not only investment in research and development, but also in education, infrastructure, and legal systems that can support and regulate these advanced technologies. Scientists at the forefront of AI and genetic research face a unique set of challenges. Balancing the pursuit of knowledge with ethical considerations is not always straightforward, especially when the potential for significant breakthroughs exists. Researchers must navigate a complex landscape of ethical dilemmas, from potential conflicts of interest to the broader implications of their work on society. Support systems, including ethical training and clear guidelines, are essential to help researchers make informed decisions that align with societal values and ethical standards. As we conclude this exploration into the CIA's intersection with AI and DNA manipulation, the need for a balanced, visionary approach is clear. The potential of these technologies to transform our world is immense, but so are the risks. A future where innovation is guided by ethical considerations and where regulation keeps pace with technological advancement is not only desirable but necessary. This essay serves as a call to all stakeholders, governments, scientists, citizens, to engage actively in shaping the trajectory of AI and genetic technologies. By fostering a culture of prudence, ethical responsibility, and inclusive dialogue, we can harness these powerful tools for the good of all, ensuring a future that respects both human rights and scientific progress.